All right, we're back, and we are COMP123 in the summer 2017 semester, and we are week 10. I think this is part 1. I'm not sure if I'll do part 2 this week when it comes to recording. We'll talk about why. So things that are planned, some announcements for this week. We are going to have a little quiz on Thursday, right? It'll be an individual quiz. Yeah. It'll be an individual quiz. It won't be a lab. And we'll be talking about concepts of the stuff that we've discussed so far: inheritance, polymorphism, GitHub, interfaces, abstract classes, those kinds of things. It'll be worth 0.5% of your final grade, so not very much. The same as a lab, right? And it'll probably be around 10 questions. Okay, so it's going to be an online quiz that you'll have to do here physically. And it won't start immediately when we come to class. I'll start it sometime into the class. I'm not going to tell you when. And then it'll be done. You'll have 10 minutes to complete the quiz, and you'll be done for the day. All right? So there won't be any homework this week other than the quiz. You'll have access to everything, but you have 10 minutes, which is good luck for you, right? So you may not answer all your questions. The idea is that it's not for, that I don't want to give free marks away. It's not about that. It's about you understanding, or it has to pass through your brain a couple times, these concepts, so you understand what they are. Okay. I'm going to cover a couple of these things. I've put a new PowerPoint on. There's a couple of errors on the PowerPoint, but I'm also going to be covering the PowerPoint from last week a little bit. So I'm just going to go back down to around, if I'm not wrong, slide 55. Talk about that a little bit. I'm also going to be adding in, I'm close this one down. And my solution, close it down. And I'm also going to be going to I'll do 9A with you guys. 9B. All right. Doesn't really matter. I'm going to start with this one. And just to show you what we had from last week, we had, when it starts off, I actually did 9A with you, even though you guys are 9B. Right? You guys are B, but I did 9A for a reason. But that's okay. If you notice in my class diagram, right, last week, one of the questions was, hey, can I make a supervillain class? That's what I asked you guys to do, right? Supervillain. And in the first class, I went through how to build the supervillain class with them. All right, so I'm going to do that with you here. So what I need first, if you remember the lab did last week, right, is you needed another interface. You needed an Ai has malice interface. That's what I asked you guys to do, right? And a supervillain class. All right, so based on the superhuman class. Okay, so here's superhero, and now I'm going to make another one over here. Let's make another interface. So just a review. I'm going to make a new interface, right? It's going to be called Ai has malice, right? Here's Ai has malice. And Ai has malice, this interface. What's the special thing about interfaces that we have to do? I'm going to do this very quickly, so I'm not going to comment very much here, but let's just put in this interface. So the interface for Ai has malice, remember, it's going to implement the malice method, right? Which is going to return an amount of malice integer. So here's malice, right? That's what it's going to do, right? But it's going to be a property, right? So how we write properties is like this. We say prop. That's a quick way. But we can't use public, right? We can't use public because in interfaces can't have public or private access modifiers. They're all public. Okay? That's how it works. There's my interface. And because I'm building an interface, I'm going to go to, I have a new file I've just added, which is Ai has malice, this new interface. So I'm going to put this new interface together. So again, I'm doing it a little differently than I did. Now we're at the 18th today, right? And I'll say this is the Ai has malice interface. And 0.1 is I added the Ai has malice, or created. I'll say created, not added. Created the Ai has malice. If I can spell, I cannot spell today. And plaguing me. I has malice interface. There we go. So I created it. Okay, good. So now I'm going to go to team. I'm going to go to changes, and I'm going to say added I has malice interface. Okay, commit all. Yes. Home, sync, and push. So you guys have that too. Again, so I'm giving you the solution. Right? That's great. So that's this part of the class diagram. Here's I has malice, right? And create another class, right? That it inherits from superhuman called supervillain. Let's try this out. So again, I'll probably put it down here. It's another class, which we'll call supervillain. Right, there it is. There's a supervillain class. And my supervillain class will inherit from the superhuman class, right? And implements the I has malice interface. But we have a problem, right? When I do this, I have these little underlines. Well, there's a really quick and dirty way to take care of this. Does anyone know how? If I hover over the supervillain, right? Notice this little light bulb, right? If I click down onto it, I can say generate constructor, boop, right? And I can do the same thing for the I has malice interface, right? I can kind of go over here and go to the little light bulb and then implement interface, boop, right? And it codes it off for you. Was that? Tricks. I got to tell you the tricks because these are the fast tricks for rapid application development. And I think it's good to know these things. Now, I still got to order things. Just because I did this doesn't mean I'm finished, right? I still got to do something like this. I still got to make a private instance variables, right? To make it like the same as the other one, right? So it's going to be a private integer, which is malice, right? And I also want to make public properties, right? And this is the public property malice it's going to be, but these are stubs. This is just a stub for the property because it's got this not implemented exception. So I want to get rid of this. And it's going to be coded that this dot underscore returns, right? Return, rerun. Return this dot underscore malice. That's what I want to do. And this is going to do the assignment, right? The set. So this dot underscore malice is equal to value. Yay. There we go. Right, so that basically does most of what I want. My constructor is not complete. The constructor, remember what I wanted you to do is maybe take in the malice value. So I'll say malice, lowercase. And I don't really code it this way. My style looks like this, but it's okay. Right? Kind of less to do, right? And I'll say this dot malice, capital M, is equal to malice, lowercase. All right, so I've got everything done now, right? That's the class. So I did the class in 2 seconds, right? And let's do some commenting, right? So I need to comment for my constructor, // this is the main constructor, right? Let's say it takes two, I'll put this on the next line this time, just to be different. It takes 2 arguments, name, which is a string, and malice, which is a it. There you go. Okay, cool. So I've got that part done, and I might as well comment my class and everything else because it's another file. It's going to do all this kind of stuff here too. This is all the commenting. It's like a little bit of overhead. I know people are like, man, it's too much overhead. I don't understand, right? It is. It's a little bit of overhead, but it doesn't bother me too much because I know it's going to help me later, right? So this is the supervillain class. Right? And I'll say created the supervillain class. There we go. Supervillain class. And I can also say something like it inherits from the supervillain class and implements the I has malice interface. And maybe if I really want to, I can take all this stuff and put it on another line. It doesn't really matter, right? And same thing here. If I want to say the class, I want to go really specific. This is the supervillain class. You can see where it can be used. I'm giving you examples, but this is definitely not the only way you can do it. Okay, cool. So I've got all my commenting. I've got my objects. I'm going to put this up on GitHub. So team, right? And I'm going to go to home. I'm going to go to changes, and I'm going to say something like added the supervillain class. And yeah, that's right. Right. Commit all. And home. And push. And that'll push everything up to the. That'll push everything up to GitHub. Yay, cool. Let's take a look at my my class diagram now, right? So I'm going to go to solution, and I'm going to take a look at that class diagram again. Here it is. And notice what it looks like. It looks like this. It looks like there is a relationship between superhero and superhuman, as well as supervillain and superhuman. One inherits from I has malice. The other one inherits from I has karma. Those two things, right? And that's my class diagram. Okay, let's test it. So I'm going to go to my program class, my driver class. And I'm going to say something like this, right? I'm going to create my superhuman, so my supervillain. Testing. Right, so supervillain is equal to a new supervillain. This is something you should have got if you did this properly. We'll say supervillain dude. And then we'll make this just to change it. We'll say make this guy superhero dude. Superhero dude, supervillain dude. There we go. And I got to pass in an amount of malice. I'm going to say he's equally malicious, right? And we'll say superhero or supervillain dude, right? Supervillain, lowercase s. Supervillain dot add power, and we'll say the add power we're going to add for the supervillain is. We'll say shadow casting. We can cast shadows because he's a super villain. And the power rank will be 50, sure, just like the superhero. And the supervillain is also going to have a power. See what I did? Supervillain lowercase. I meant this one. Add power. My naming convention, that's kicking me. Shadow casting and mind control. That's pretty evil one too. There we go. Mind control is always evil. All right, and you know, just to be different and more powerful than the superhero a little bit, we'll even give him a third power, right? So maybe we'll say something like combat senses, right? Combat senses of 30. So it means like our super villain actually has better spider senses than a spider guy, because Spider-Man didn't have spider senses in the new movie. All right, so I will do one of these, and I'll say supervillain dot toString, right, which I'll show our supervillain, and I'll separate them with a console write line just to be a little bit different. Oops. Console write line, and let's check it out and see what it does. It does this. I have two. I have a superhero dude, very different from the supervillain dude. Both are based on the superhuman class and implement different interfaces. Okay, very straightforward. And I can also say that .8, I implemented the supervillain class. Okay, and this is demo for lesson 10, which I didn't do before. And now that I can do that, I'm going to go to Team Explorer. I'm going to go to Home. And I'm going to go to changes. This is Del 1, and I'll say implemented the supervillain class in the driver class. Driver class. There we go. Commit all, home. And I will go to sync and push. And that pushes everything. So you guys have everything. That's the solution for the lab number 24. It's up on GitHub if you want to compare mine with yours. Okay. And that would be for, oh, one thing we missed. I said solution. Well, we're not quite there. I also asked you to show the malice, right? And the way to do that, of course, would be, I don't know, do another like console write line. I think I didn't do. So let's do another CW. And then what I want to do is something like malice is equal to plus supervillain dot malice. Just a very quick and dirty way of doing that. And you can see that now that's what I asked you, right? Malice of 20. And one thing I didn't do with this iteration of the code is actually show the, so we'll do a console write line, and we'll do the superhero.karma. So superhero.karma, and I'll say something like the same thing, which is karma. Go, and now I'll add another console write line. All right, there we go. Now that is pretty much better. Okay, that's perfect. Okay, nothing fancy or special, guys. Nothing to really worry about. And now after you've done this, I said last week that you were able to do assignment number 4. Okay, because this gives you most of what you need to do your assignment. Okay, cool. So this is 1, and this is good, but I want to continue where we left off from last day. I don't want to redo all this work, right? And there's got to be a good way to be able to copy what I have here. One of the questions I got an email was, how do I make a copy of my code and rename it? How can I rename my project? And there is no real way to rename your project properly without creating something called a template. So let's do that. Now you're going to need this for your final exam, so please pay attention. All right, so what do I mean by this? So here I've got a good working project. I like it. But I want to make a new project demo for week 10, all right, as an example, right? How do I do that? So I'm going to kind of file. Here's the first part, export template. Okay, here's my project template I want to export. Notice that it says 9B, right? That's okay. It's looking at the project that's inside of my solution. Maybe I have more than one project in my solution. Here you can select the project you want to create a template from. Okay, in this case there's only one, so I click next. Next, I can name my template. I'm going to call it 9B for now because I already have 9. Right, and then finish. That's it. All right, it's going to pop up this area here, which is my exported templates with a bunch of zip files. I don't need this. I just close this up. Now that I got there and I exported my template, I mean, really, that's all there is. I can close this down. So close my solution, and I can open up a new project. So File, New Project. And once I do this, once I create this new project, it's based off of a template. I can find 9B. Here's 9B, right? So instead of doing what I normally do, which is when I go to C#, right, I look for console application. That's what we normally do, right? I don't want to do this anymore. I want to go to C# and scroll all the way down, or you can search here for COMP123, right? And notice that I have a couple of templates, and this is the one that I just made. I want to use this one, 9B. And I want to rename this thing 10B, right? Notice that here's my Git repository. I've got this checked, right? And so what I'm really doing here is I'm basing my new project off of my old one. So here's my old project, 9B, and I'm making a new project, 10B from 9B. If I press OK, then I have my new project with everything inside, but renamed. And my new name is 10B. Why would I want to do this? Okay, let's think about the exam. I give you my exam. You take that exam, use it as a template, and make your own with your student ID. Right? So now you're effectively, quote unquote, renaming it, right? But you have another copy of it, right? The original template that I gave you is pristine and untouched. I didn't touch that template. I just do this one. We also do this when I want to have a template to start from instead of starting from scratch. I don't want to start from scratch every single time. Maybe I have some really cool classes and objects that I want to reuse when I do another application, and I can use this method to quickly create my new project from my old application. Okay, remember, it's easier to create, right, when I have something that I already created from before. It's easy to destroy stuff. I can always take stuff out. If I don't want some class or whatever from here, I can take them out. But it's way more difficult to make it up from scratch, right? And for me to redo my class diagram, all my my super classes and all that stuff takes a lot of effort. Okay, so I've got this. This is the one I'm going to be working with today. Now I got to put it up to GitHub. Now the first class, I had a bit of an issue with GitHub because I had problems connecting for some reason. Problem now. And if I do, I'll show you how to get around that. All right, so here's my Team Explorer. Notice that I don't have any GitHub. I'm not connected to GitHub right now. Right? Why? Because my project doesn't have a Git repository that I'm linked to. Right? If I click Publish to GitHub now, it's going to say, "Oh, sign up to GitHub." And this is the problem that I had. All right? It's like it doesn't know who I am. See where it says sign in or sign up? That's a problem. Okay, sign in or sign up. It should never say that here, right? So if I type my name, it's my GitHub name, right? And if I put my password in, I think I know what it is. Okay, this is the problem I had earlier. This is really bizarre, right? Okay, suddenly it takes it for something. Yay! I don't have to show you that other part. Okay, cool. So now it's logged me in, and if you notice, it says me. That's my account. I don't want that. I want, Centennial. So I'm going to go here, Centennial. It's going to add it into 10B and click Publish. So now I've done everything that I can. So now if you want to follow along, please look at 10B, right? Don't show this again. Please look at 10B up on GitHub. And if you want to find where that is, for those people who don't know where my GitHub account is, it's on github.com/Centennial College. All right, so that's the account that we're going to be using. All right, so there's 10B. We did 9B, right, earlier, right? And there's 10A. Somehow it came over here. Here's 10A, here's 9B, and then there's 10B. That's what we're going to do now. Okay. Let's go back to concepts. Okay, so one part of what I'm going to be doing this week, again, is talking about some stuff from last week's inheritance and polymorphism PowerPoint. And then I'm going to be talking about some new concepts, more advanced stuff today, right? Which some of you may go, what the heck did he just do, right? Please stop me if you think that there's something that you really don't understand, because that would be really bad if you don't get it. And I'm going to just keep going, right? And fine, the video will be there, but you won't have your answers if you have a question. All right, so we talked about multiple inheritance. There's no such thing as multiple inheritance. We talked about interfaces that help us with composing classes, right? And one thing we didn't talk about last week was the idea that we can instantiate concrete objects from concrete classes, but we can't instantiate concrete objects from abstract classes. We talked about that. If I was going to ask you in your own words, what is the difference between an interface and an abstract class, what would you say? So you're going to be recorded for all time on YouTube. Go ahead. He's like closing his eyes. Go. Yeah. So what happens? So I want other people to come to the front too, so I can ask you. So if I see you, I'm going to ask you. Right?
Difference between
interface and an abstract class. Yeah. What is it?
Well, interfaces, they can add methods, but you're not necessarily inheriting abstract classes.
Keep going.
You inherit from an abstract class if you're reading it.
Kind of, sort of.
Is that what your question was?
No. So interface, difference between interface and abstract class. Interfaces, abstract classes can be inherited from interfaces.
Well, interfaces, they don't create
objects, right? Yeah. Abstract classes, you can't make objects from abstract classes either, but abstract classes are like blueprints for other classes. Interfaces define the signature for methods, right? Or properties, right? And anything inside of an interface must be overridden or must be implemented, right? In an abstract class, you can have abstract methods and methods that are non-abstract, right? And that's the difference, right? We use both abstract classes and interfaces to create blueprints for other classes, all right? Or to create a structure for the other classes. And we use interfaces, we subscribe to the interface, and we make sure that we implement all the properties and methods from that are listed in the interface. Notice that I didn't say defined. We don't define the method. The method body or the property is there's nothing inside of it. We define that method body inside of the class that implements the interface. Okay? I know it's a long, convoluted answer, but you're going to see another one that's a lot nicer than mine. So if you're ever asked on an interview, that's the difference. You need to understand the difference between an interface, an abstract class, and a concrete class. You need to know those things, right? And that's why I'm doing your little quiz on Thursday, because you need to understand a few some terminology. It doesn't have to be a lot, and I'm not going to ask you this question again. So I'm not going to retest you at the end of the day, you know, on your final exam, right? Your final exam most likely will be practical. I'm not going to have true, false, multiple choice kind of stuff on your final, okay? So that's what interfaces and abstract classes are. One thing we didn't talk about was something called extension methods. Now, extension methods, I'm not going to go through an exercise or a demo for this, but I want you to know this. Whenever we create a method inside of a class and we use the keyword this in front of the type of the parameter, C# looks at that as an extension method. And what extension methods are used for is, let's take a look at a normal data type, like for example, integer or a float or a double. And instead of, we can't really modify those. We can't inherit from those things, right? I can't inherit from an integer. I can't say my new class is of type integer. It is an integer. Can't do that, right? Because integer is a data structure, right? Integer is not a class, right? String, on the other hand, the capital S string is a class that you can inherit from. Well, actually, no, it's a seal class, but we'll talk about that later. All right, so that's one of the things that you know, that we can do. We can use the extension methods to do this, and the extension can extend basic data types that are built into C#. How does this work? Let's suppose that I have my class, and I have a method called add check digit. All right, that's the method. It is a static method, public static, and it returns an integer, right? And notice I'm taking in a value, right? It looks like in the signature of the method that I have integer and num being the local variable that I'm taking in. But then in front of this, I have the this keyword. And this is what C# looks at. It looks at this structure in my signature and says, ah, it's an extension method. And that's the only thing it looks at. That's the only thing they can tell that tells C# that it is a extension method. So what does that mean, extension method? Well, it means that I'm extending the integer data type. That's what I'm doing. So I'm in the integer data type, I'm actually making it bigger. I'm adding a method to the basic integer just for this particular method, okay? Or for this particular class. So an example in this method, I'm saying here's the first integer. I'm going to take the number divided by 10. And then whatever that first number is going to hold, whatever number I pass into it, divided by 10. So if I pass in 49 as an example, what's 49 divided by 10? 4.9, but I can't get the 0.9, so it's only 4. So 4 gets stored into the number, right? Into the first. And then second, okay, cool, second. My number, right? And then modulus 10, right? What's the remainder? 9, right? So the second number is 9. Here's the third number. The first number plus the second number, so 4 plus 9, right, is 13. And then modulus 10. Right? That's 3, right? Because 4 plus 9 is 13, right? Isn't it? Mod divided by 10, right? Divided by 10 is 1, modulus 3. So remainder 3. So I'm going to take 3, and that's the third number. So 4, 9, and 3, right? And so the result is whatever the number is, right? So 49, so 490, plus the third number, 493. I don't know why. Who wrote this thing? I don't know, right? But that's what this thing does. I'm just saying, right? If you're going to trace it, right? And so the result is 493, okay? And it gives you that result right here. So here's how you implement it. Here's the number. The account number is 49, right? And then here it is. Here's me using the overloaded, or if you will, the extension method for account num. Account num is an integer, but I'm actually adding in, integers don't have this add check digit. It doesn't have that, right? I've just made it here in my extension method, data type, right? And then when I do this, add check digit, right? When it outputs the digit, it looks like 493, like we said, right? Convoluted. We're going to have a lot of convoluted things today, but this is one thing we use. Now, I'll tell you this. Extension methods are really cool. I'm going to go back to the extension methods. Extension methods are really cool they're not just used in C#, but other object-oriented language, especially Swift from Apple, the language we use to program iOS devices. We use extension methods all the time. All right. So to learn extension methods is really, really cool. And we're going to see it later on in programming 3. Okay. Let's move on. So that was this. That's the only thing that I didn't cover from last week, extension methods. I just want you to know about it. Am I going to ask you about it on the quiz next day, like on Thursday? No. I want you to know about it, but it's not something we've implemented, so I'm not going to ask you about it. Okay. What I am going to ask you is, hey, what's GitHub for? Right? I'm going to ask you. These are the things I'm going to ask you. Right? Like, how do you do certain things? I'm going to ask different questions, things that we've talked about in class. I will ask you for sure, 100%. Right? All right, so today, what are we talking about? Today, we're really extending our inheritance and polymorphism. We're talking more about this in more detail, right? This is like the second or third week we've been talking about this now. We're also going to be talking about how do I compare interfaces in abstract classes. I'll give you a bit of a definition there. We're going to be talking about a couple of interfaces that are very common, that are used all over the place in C#, so built-in interfaces that we use, right? What the hell is the is operator? We're going to talk about that. If we can get to operator overloading, that would be really cool. And then if I can handle sealed classes and methods, I will. We'll talk about what that is as well. Okay, so those are the 5 things I want to talk about today. I'm going to extend this example for next day. So Thursday, we're going to be talking more. I'm going to add to my class and do more stuff, right? And we're going to, of course, do our quiz. All right, so what's the difference here is a good example of we talked about abstract classes and interfaces, and this is right from the book. Interfaces and abstract classes provide signatures for properties and methods that a class must implement. Must implement, okay? All of the methods, members of an interface are abstract, 100%, right? In contrast, an abstract class can implement some or all of its members, right? So in other words, I may have some abstract members, but not all of them have to be abstract, right? A class can inherit only one class from only one class, including abstract classes, but a class can implement more than one interface. And one thing I want you to also notice is that interfaces can also inherit from other interfaces or implement other interfaces, which is pretty wacko, right? And what would you think why would I want to do that? Why would I want to implement other interfaces inside of an interface? Why would I want that? And I would only implement the signature, by the way. Anyone have an idea? Well, if I have a bunch of interfaces that are related, right? Like, imagine if I have a human, the human can walk, the human can talk, the human can do a bunch of different things, and they're all related. They're things that he can do, like behaviors, common human behaviors. Maybe I'll have an interface that says, common human behaviors, right? Right? And then that'll include all the other interfaces all built in. So it takes up one line when I inherit from superhuman, as an example, right? As opposed to I have to list every single interface on the class that's inheriting, right? That's a good reason. And there's other ones as well. It solves some problems, as always. Here's some common .NET interfaces. You'll see these all over the place. Ai Cloneable, Ai Comparable, Ai Convertible, Ai Disposable. These are ones that are built in. Remember, someone asked me, I don't really understand interfaces. They make no sense to me. I think, why do we use them? Well, sometimes we use them to compare, to make sure that one object is an object that implements the Ai Comparable, right? So I can check to see if you've implemented that interface, and if you have, then I can do certain things, whatever behavior I want. Here's some other interfaces: Ai Enumerable, Ai Enumerator, Ai Collection, Ai List. These are other ones that are used by collections. And next week on the plan is we're going to be talking about collections. And the week after that, we're going to hit user interfaces. Just FYI, I may move these up a little bit. So I may start talking about collections next day. And I may start talking about user interfaces next week, as opposed to the week after, because then the more time you have with user interfaces, the better. Because that'll be your next assignment. Okay. All right. So so this is some common interfaces that we can use. And here's an example. I'm just talking in detail now about interfaces again. Right? So here's the type, and here's the method. So this is an abstract method that you define in the interface. Notice there's just the signature. And here's your property. And notice that the get and the set are optional. That's why the square brackets are. Okay, so I can just whatever the property name is, I don't, whether I want to or not, I can leave out the get set. All right, cool. So that's the example. Here's some interface examples. Interface, iDisplayable, and I have this thing called getDisplayText that takes a string, and the string is a separator, right? This is an example of an interface for those people who missed it last week or who didn't get enough of interfaces. And here's another one, right? That implements one method, and this one implements two methods. So here's two methods, read and save, and it also has a property. Right? So interfaces can be more complex or less complex, depending on what you require. And here's the example of a syntax of interfaces that implement other interfaces. So here's an interface, whatever the interface name is, colon, and then however many other interfaces it implements. And notice that these are all the interface members that you would list here in this interface, right? So one interface that implements from the other ones, and that way you can have an easier structure when it comes to inheritance. Okay, and there's a concrete example of it. Okay, here's an example of Ai Cloneable. I want to use, so in this particular case, I want to use iDisplayable, and iDisplayable is this one, right? We kind of defined the iDisplayable interface up here. The iDisplayable interface is going to take, here's iDisplayable, getDisplayText. That's what it's going to do. We have to define a method called getDisplayText, right, for iDisplayable. So it's inheriting this one and Ai Cloneable. And remember, I told you Ai Cloneable is one of the most common interfaces that we use in C#. Why? Because we can clone a piece of code. So if I say, here's my class, I want to clone my class, I can do this, and it's not so bad. It turned out to be bad at all. Okay, so how does this work? When I say clone classes, what do I mean? Well, here's the implementation. So here's the clone method. It returns an object. Remember objects? Big O, right? Remember what object is? The super duper class of all objects. Object means, so it's returning an object, right? In this particular case, now I would never code it like this. P, this is right from the textbook. P and p.code, p.description, p.price. P represents a new class of the same, the product class. And I'm really, what I'm doing here in this example is, this is the product class itself. But inside the product class, I'm creating another product within the product class. Kind of using its own class to do that, right? So P represents a new product. So the product code, the new product code is going to be the same as this class's product code, and so on, right? So I'm basically copying from one class to the other. That's all I'm doing. Quote unquote cloning. I'm cloning one class to the other class, right? And from an implementation details perspective, right, when I use this thing, I would say whatever the class is, the instance.clone, and then that will return another object of the same class that I can assign to another class. And this is the ability for us to use the Ai Cloneable interface. All right. Again, did I show you a demo? No. Am I going to test you on Ai Cloneable? No. Should you know the name? Should you understand that there's a bunch of, the idea that there's a bunch of interfaces that the C# has that have been predefined that you can use? Absolutely. You should understand that it's not me making the interfaces, it's C#. Here's a special interface called Ai Comparable. Notice the two angle brackets, right? Angle brackets mean type. So this is a generic interface, Ai Comparable. And notice that what we can do is the member that it generates is compared to. Okay, that's what it generates, compared to. So Ai Comparable, angle brackets, it needs a member called compared to, and returns an integer. Okay, cool. How does this work? So here's the so this is a product class. It implements Ai Comparable, and the type is product, right? It's almost like I'm taking this class itself and using it as the type that I'm comparing. Okay, I've got a few properties: code, description, and price. These are properties. And now, my friends, this is where things get funky. So please pay attention, right? Public int compared to. This is the method that implements the Ai Comparable class, the uncomparable interface. This method is linked to it. This is the interface method, right? Interface member, if you will, right? And notice that I'm passing in a product instance called other. This is the product class. I'm passing a new product instance called other, and then I have this really weird notation. What the heck is this? Anyone know? Anybody? It's called a Lambda expression, and you're going to learn about this in programming 3. Okay? Other languages use fat arrow syntax, right? So when you see this equals and greater than, it means a Lambda expression or fat arrow. And what I want you to think about it as when you read it is returns. So public int compared to product other returns this. And this is another funky thing. So here's code. If you notice, code is of type string. String is not a simple data type, right? String is actually a complex data type. If you think about what a string is an array of characters, right? That's what it is. It's a complex data type, right? And because it's a complex data type and string inherits from class capital S string, right? It also has a compare_to method built into it. So we're using the compare_to method built into the string class, which is what code inherits from, right? And I'm going to take other code, which is the product that I'm getting. So the other product's code and comparing it to this code. So I'm looking at this code. Let's say I have a code for the product code, 123, right? It's a string, right? And I'm saying, hey, take the new product code that I want to compare to, and compare my new product code to the product code that I have in this class. Now it's written so succinctly, right? It's written so succinctly and in one line kind of thing. This is one big line, and this is where Lambda expressions can be quite confusing to new students who are beginners, who've never seen a Lambda expression before, because a Lambda expression actually replaces things like this: curly brace, open curly brace, if other.code, right, is equal to this .code, then return 1 or 0. If it's greater than this .code, return 1. If it's less than this .code, return -1, right? That's what this does in one line. Okay? Because the compare_to interface is built into the string, all the heavy lifting is done by the built-in string compare_to method. I don't have to rewrite this thing. Okay? But that's what it would really look like if I was going to rewrite it. So this is what it returns. When it returns values, the compare_to method returns -1 if the element is less than the compare element, 0 if they're equal, and 1 if the compare element, if the element is greater than the one you're comparing to. Okay, that's what it does. That's the compare_to method. All right, anyone not understand that? And if you understand that, that's fantastic because it's advanced, right? And are we going to cover this again? Absolutely, in programming 3. And when next week, or maybe on Thursday, when I start talking about collections, I'm definitely going to be talking about the Ai comparable interface, right? I just don't want you to be scared. And there's different ways of writing this lambda, so you don't need a lambda. You can actually write a real method, all right, and a complete method. This is the most efficient way, to be honest with you, right? But it doesn't mean that there's the only way. There's other ways of writing it as well, and we'll do that. Okay, but don't be afraid. If you once you see this, you're like, what the hell is that fat arrow? It means lambda expression. It means returns. In your mind, for now, I want you to think about it as, hey, this method returns this stuff. That's what it returns. Okay. All right. So lambda expressions. How about the is operator? And then I'll do a little demo for this one, right? So is, it's kind of weird. I mean, it's almost like it should be has or is type. That's what it's kind of like, right? So think about this, right? If I take a look at my operator is, right? Here's my operand. So let's say, for example, superhero. I want to say something like this. Is superhero superhuman? That would be the type. And the answer would be, yes, it is. So I can compare, I can look at an object, right, of a class and say, yeah, it is an object of type class, whatever the type is. Let's try this out. So I'm going to try this out in code. So if I'm going to go to my solution, I'm going to go to my program, right? And down in here, what I can do with the is operator, by the way, I may ask you questions about the is operator. It looks like this, right? I can say something like this. If superhero, right, is superhuman, right? Is it a superhuman? Superhero or superhuman? Right? Hold on. Let's try this out. Then console right line, superhero is a superhuman, right? Remember we talked about is our relationships? That's what this is, right? So if this is true, this is the way you do it. Is basically compares superhero, the object, with another class or something else, right? So let's try this out. And if I press Control F5, right, then I should get superhero is a superhuman. It's true, right? Because superhero, even though it inherits from superhero, capital H, right, is still a superhuman. How about this? Can I do this? Is this true? Yeah, right? Superhero is a human as well, right? That's for sure, right? And actually, let me undo these changes for a second. So I'll just write this whole if statement again, right? Let's try and make a bunch of this. A superhero is a superhuman. Superhero is a superhero. So that's also true, right? Hero. There's a superhero. How about, and we can also go one step back. So superhuman and then human. Human is definitely a human. These are all the relationships that you can check for, right? So it's also a human. These are all true, right? And we also know that superhero is also an object, right? Can I do this? Right? I think this is a pretty good example for you guys to understand what superhero is. So let's try this out. Let's just run this thing and see what it gives us. It's going to give us a bunch of results. And if I'm right, then we're going to be good, right? Uh-oh. Where's the error? Did I kill something? Oh, yeah. I added an extra one of these, right? I don't know how I did that, but it was a copy-paste error. Let's try that again. Yeah. Yay. So superhero is a superhero. It's a superhuman, a human, and an object. We know that, right? Why is this true? Because superhero, right, inherits from superhuman, who inherits from human, and of course all objects inherit from the object superclass, right? So these are all true. But what about if I do one of these? Can I also do this? Can I say if superhero is I has karma? Can I do that? And the answer is yes, I can do this too, right? I can compare if it also has an interface. Superhero has karma. That's what I'm really saying. Does superhero have karma? And the answer is yes, I do. Right? And if I run this thing, Control F5, then you can see that superhero has karma comes up true, right? So you can use the is operator to check to see not just of objects, right? But also which classes superhero inherits from in this particular case. And you can also check to see what it doesn't. Like, for example, how about this? If superhero is it a supervillain? Can I do this? Right? I mean, it's possible. I could do that, but look at the underscore that I get. It says the given expression is never of the provided supervillain type, right? It even tells you right there it's not true, right? I mean, I could make this happen, but it would never work. I would never get an answer to this, right? Because superhero is not a supervillain. It's a sibling. They're related, right? It's like brother, sister, superhero, supervillain, right? But they're not the same because one has malice and the other one has karma, right? That's what makes them different, very different. All right, so just wanted to give you an idea of how you can use the is operator, Okay. I'm not going to save this thing. I just want to show you how you use it. It's very useful when it comes to making decisions, especially when we want to compare one object to the other. All right. Questions around the is operator. It's kind of a useful little thing. All right, so that's is, right? And there's some really good examples of it. It says, hey, if the type, so remember, it's like this. It's operand and then type, right? If the type is a class type, then the result is true if the operand is of that class type, right? If the type is an interface, then the result is true if the operand is of that type, or if it is a type that it implements. That means if I have 5 different interfaces that my class implements, I can check for any one of those interfaces to make sure that that it filters through. So I can check an object and make sure it's the right type of object, that it's been constructed correctly, right? And that's a really good thing. And there's another option here, which we're not going to talk about because you guys haven't learned about boxing and unboxing yet. Okay, you will probably learn about that in programming 3 when we talk about the stack and the heap. Okay. Anyway, so here's another thing we're going to try today, and this is something we're going to work on for the remainder of class, right? Something called operator overloading. Okay. So not only can I extend built-in data types like integers and floats and doubles and all that kind of stuff, but I can also overload built-in operators. And when I mean operators, I mean things like plus, minus, right? Greater than, less than, right? A bunch of other ones, right? And there's different ways we can overload them. We say overloading because what I'm really doing is I'm rewriting what those things are going to be doing, right? I'm rewriting what the plus is going to do for that particular class. Like, it doesn't make sense if I say, okay, if I want to take one object and add it to another object, there's got to be something that I'm adding. I got to know what I'm adding together because objects are complex. They have different properties. Which property am I adding? I can't just say like add one villain to a hero. It can't work, right? That doesn't make sense. But I can compare things, right? So sometimes this is really useful, and I've personally used my overloading operator overloading for things like when I create things like vectors, right? If I want to add 2 vectors together, vectors have, let's say, x and y coordinates, right? Or x, y, and z coordinates if you're working in 3D space, right? If I want to add one vector to another vector, right, the plus operator can be overloaded so that it understands that x1 plus y plus x2, right, is what I'm looking for. And then y1 plus y2 and z1 plus z2. That's what I want. And the resultant vector is going to be x1 plus y plus x2, comma, y1 plus y2, comma, z1 plus z2, right? Adding one to the other, operating overloading, right? Or if I want to multiply vectors together, or if I want to create matrices and I want to multiply matrices or use dot product or something like that, I can create whatever stuff I want here with operator overloading because the implementation is whatever you want it to be. But I also want you to think, be reasonable when you create an overload like the plus overload. Make sure that it adds these 2 things together. Like, don't use plus to do some other funky thing because then users will be confused. Why is he using plus to do this operation? It doesn't make any sense. It has to make sense from a business perspective, right? All right, some rules. So whenever we use operators to overload them, we must use the static keyword. They're all static, okay? They cannot be other than static, because imagine if I have a class and I have to instantiate an object to compare, that doesn't make any sense. We should never have to instantiate the object that we want to do to compare the 2 objects together, right? And you can have multiple uses. That's the other thing. We can have unary operators, such as minus. And remember what minus does. If I say my width is minus height, width is equal to minus height, what I really mean is take the negative height value and assign it to width. That's a unary operator, right? It's different than width minus height. That's a different thing, right? That's a binary operation, right? So we can use unary and binary operations of operands as well. Okay. here's an example of the add operator. Okay, so I have a class. Here's my public static add class, right? And add class, this is my class, and what I'm returning is another object of that type of class, right? That's what I'm doing here, right? I have to use the keyword operator. So these two things, static and public, are all required. These three things. So public, static, and then operator. And then the type of operator you're overloading. In this case, the plus. Okay? So I take one object on the left-hand side and one object on the right-hand side, right? And then what I'm doing is I'm doing an add operation because each object has a value, right? There's the value that I'm adding together. So I'm taking value 1 and value 2, adding them together, and I'm returning that value. And that's going to be returned as a new object. That's what I'm returning, a new object of that class. Now, this is a great example because what it does is it also creates a new object, a new member, a new object of that type of class that you're creating. But the funky thing is we're calling the class from within itself, right? We're just defining the class here. We're actually using it for the definition right here, which is something you've probably never seen before, right? So here we're defining it on the top, and then here we're actually creating and using it, right? That's within the class definition, right? Which is kind of funky and advanced. It can look advanced. It's like your mind has to wrap around it, what I'm doing here. All right, so this is something I want to do with the powers. I want to have the power ranks, the superhero powers. And what I want to do is I want to compare them. I want to say which power is greater than the other one. Is power A more powerful than power B? How can I do that, right? Because powers are complex structures, right? Powers have a power rank and a name. I can't just, they're not just numbers, right? So I have to use this overloaded operator method to do that. Okay. Here's another example. That's the binary, that's the unary example, right? The binary example. Here's the unary example. The unary example, right? Here's the binary one, the plus with two operands, and the unary one is on the next page, where I flip the sign. Okay, so minus only requires, in this particular case, the way I'm using it, it only requires one operand, right? So I'm doing one of these. So the value that I'm returning is the negative value, right? That's what I'm doing. I'm taking the negative value and I'm assigning it to the return value, and I'm returning this object again. Now, just to give you an idea, right? To give you an idea of what we can do, take a look. Unary operations can be done with a plus, minus, the exclamation mark, the tilde, plus, plus, minus, minus, true and false. You can override or overload all of these, right? It's interesting, true and false. Those are interesting, right? And binary operations can be done with a plus, minus, star, so multiplication, divide, modulus, and, which is not and like compare. It's actually a binary and operation where you're actually adding two binary numbers, right? The or what we call pipe, right? Or usually the caret, right? And the move to the left and move to the right. This is the binary move left, binary move right, right? You can change all of these, right? And also the comparison operators, they can also be overloaded. The equal, the not equal, the less than, and the greater than, less than or equal to, greater than or equal to. All these operators can be overloaded and changed. What we're going to do today is we're going to change this one. But you're going to see that when we do greater than, we can't do it in like singles. We got to do the pair, greater than or less than. And why is that? Because it doesn't make any sense. How can I just do compare greater, but we don't care about lesser, right? And so C# makes you do both. Same thing with equal and not equal. They make you do both of these too at the same time because they're related, right? Okay, let's get to it. Let's try this out. So I want to think about how to compare stuff. I want to be able to compare the powers from my supervillain, or any one of these superhumans, right? So it's got to be done in the superhuman class, right? It's not something that's limited to just the supervillain or the superhero. I should be able to compare the power ranks, as an example, of any superhuman, right? That's number one. I also have to mention one thing before we continue. Does anyone know the difference between a class and a struct? First of all, you guys heard about structs? Anybody? Put up your hand if you've heard struct. It's another structure, actually. No pun intended. Yeah, well, that's what they are. They're structures. That's what struct means, right? And let's take a look at them for a second. So let me take a look at the power class. So my power class, what is it really doing here? Am I doing anything specific? Am I inheriting from anything else? Not really, right? So my power class, it has two properties and a constructor. It's very, very simple. In fact, what I said was, this is like a new data type. Once I think to myself, it's a new data type, I've used the wrong thing. I shouldn't use a class. Best practice says I should use something called a struct. And what a struct is a value type, not a reference type. Syntactically, they almost look exactly the same. So I can declare a struct, and it almost looks exactly like a class. I just changed the word, like this. Instead of class, I put in the word struct. Okay? Now, this is interesting. If once I do this, what happens to my class diagram? Here's my class diagram. Oh, man, I got this, right? Because a struct is not a class. It's not a reference type, so it doesn't appear on the class diagram. It tells you something's wrong, right? So what the hell is a struct? What can a struct not do compared to what a class can do? And this is kind of extra, because I didn't put it on my little list of things I want to talk to you about today, right? So I want you to think about a struct as it's like a class, but it cannot be used to inherit from. So you can't inherit from a struct. Okay, just like we can't inherit from an integer. We can't, right? An integer is a type of struct, right? So is a float, so is a double. These are simple data types, right? So structs of our own making, we can't inherit from. Okay? Structs can't be, you can't have protected members. Because we can't inherit from them, there's no, we can't derive class from them, there's no need for protected. Public and private. There's no other kinds of access modifiers. That's number two. You cannot create a default constructor that's empty, right, inside of a struct. A struct must have a constructor that's non-empty. All right, you have to define it. It will not define it for you like a class does. If you don't define the empty constructor, a class will define it for you, but not so with a struct. Right? So you have to make it yourself. All right, so these are the things that structs have. Structs can have methods, properties, okay? Structs cannot implement stuff, right? It's much more limited. But what structs are really used for is for simple little data types like this. And they're more effective and efficient and smaller in size. Classes are a little fatter than structs. And we see structs everywhere in C++ when we do game programming, and we see them in C# when it comes to very simple data structures you want to create. Now, I'm just showing you it so you've heard it. Am I going to test you on it? No, but you will hear about structs in programming 3. So we're going to go back to class. And if you notice, when I go back to my class diagram, hey, there's my power class again, right? It's a class again. I've promoted it. That's what I've actually done, right? Struct is a lower level kind of structure, I hate to say it that way, using struct and structure, but that's what it is, then class. Class is a higher level structure. It has more power, but also fatter, right, from a programming perspective. And when I say fatter, I mean at the assembly level, all right? When you assemble a class into its binary code, right, it's fatter than a struct. A struct is much leaner, typically. Okay, so that's, and more efficient to use when it comes to simple things like this. But this is where we want to do our comparison in our power class. I want to compare one power with another power. It doesn't make sense to do it in the superhuman class because superhuman, I'm going to compare that data type, superhuman to another superhuman. I'm not doing that. I want to compare one power to another power. And that means it's got to be done here in the power class. All right. So I've got my constructors. I've got my public properties. And I want to make a new thing here. I'm going to call this public right? Overloaded operators. Maybe I'll have more than one. I will. And remember how we started off. We started like this: public, static, has to be static, right? What's a static part of a class? What does that mean? What does static mean? I already said it. What is the static? If I say static, a static member of a class, what does that mean to you? What? Belongs to the class. But what does that mean? Stays with the class. Okay. It means that I don't have to instantiate an object of the class to utilize that method or property. All right? I do not have to instantiate an object. Just like when my driver class, here's the driver class. Look, my driver program class is static, right? I don't have to instantiate a program to make my program run, right? This main method, and by the way, if we made it public, and we made this public, right? These two things public. If I made these two things public, as an example, I don't have to instantiate an object of type main, right? Or a type program. And we don't, right? There's nothing that uses program. Program is a static class. That's what we're using. And I like to call it a container class. It contains methods, utility methods that we want to use, right? So too is our operator overloading. It's a utility method, right? It's part of the class, and we can use it without instantiating another member of the class. Okay, that's why we're going to have this little quiz on Thursday, because I'm using all these words, right? And I want you to understand what the words are. I need you to understand the concepts. When you go to an interview and they ask you a question, you're like, I don't know. I don't know what you mean. What do you mean? Right? You need to know what I mean, right? Because it's kind of required. Okay, so public static is the first part. My return type. Now, this morning, this earlier class, one of our students said, "Hey, Tom, don't do the class type. Do a Boolean type, because we're going to return a Boolean. Is it true or false? Is my power rank greater or less than?" Right? So what can I do? I can say greater than. So Boolean. That's what return type is. Operator. That's the keyword that I need to use for overloading an operator, right? And then the operator that I'm going to overload, greater than. And then I need to take in some kind of operand, right, of type power. Power. And there's going to be two sides of it. The left-hand side. I'm just going to make a little thing here. I could say left-hand side, but it's too long. I'm just going to say left-hand side, and then power. It's what I mean by that. I mean that I'm going to use my operation. There's going to be an operand on the left, the operator, and the operand on the right. So I'm going to say something like, this power rank is greater than this power rank. Is it true? And it's going to return true. Okay? But guess what's happening here? Look, I'm getting an error, and it says, not all code paths return a value, and you need to make sure that requires a matching operator less than. I have to do both sides. Both the greater than and the less than has to be overloaded. Remember I told you that? So I might as well stub it in right now. So I'm going to take this, copy it, go down here, paste it, and change this sign from greater than to less than. And now it's still not taking care of everything because we need to return something, right? So it needs to return something. Well, what do I want it to return? I want to say this. I want to say, well, if the left-hand side rank, the rank of the left-hand side, the power rank of the left-hand side is greater than the power rank of the right-hand side, then it's true, right? It returns true. So I can do it in one line. I can do something like this. Return, right? If my left-hand side, the power rank of my left-hand side is greater than the power rank of my right-hand side, then that's what you're going to return. You're going to return true if this is true. That's all I want to do. That's all I'm checking. I'm checking for the power rank, right? Remember power rank? It has a number from, it's an integer. So it could be a number from, it could be a negative too. I want to check which one is greater. And so the same thing goes with my less than, it's just the opposite. So if my left-hand side, my power rank on my left-hand side is less than the right-hand side's power rank, then return true. That's all I'm saying. So there's my overloaded operators. So I'm comparing the actual one part of the data type, right? Not the whole thing in this particular implementation. By the way, you can do whatever you want here. You can also output to the command line. You could do other things. You could call other functions and methods. You could do whatever you want inside these operator overloading methods. They're just methods, right? You can do as much or as little implementation as you want, right? And I think they're really useful for this purpose. Okay, cool. So we've got these two operators, amazing, and I've implemented them. Let's comment them a little bit. So we kind of do a triple forward slash here. And it looks like it takes left-hand side and right-hand side and returns a true, right? So returns true if left-hand side rank is greater than right-hand side rank, right? And this method overloads the greater than sign for the power class, or for use with the power class, right? Oh, it's almost identical, right? And I'm just commenting here because these two things, the greater than and left-hand overloaded operators, right? I'm going to do that right here. So I'm going to kind of do the same thing. So triple forward slash, and I'm just going to take this one instead of copying and kind of making that all out. This is this less than, right? And for the return, I'm going to talk about what this is. Just copy and paste here so we have some more comments, right? There we go. So why am I doing this? Why am I doing these comments? Someone asked me earlier, like, again, like, why do you do these comments? Well, this XML stuff, what it does is it actually gives you good code hinting when we use power, right? It tells you how to do these two operations, right? Okay, cool. Since we've done this, we also have to come up here and say this is version 0.3 of the power class, which was we added overloaded the greater than and left than operators, right, for the power class. But I'm going to take this whole comment right here, and this is going to be the thing that I'm going to put up on GitHub, right? This part right here. So I'm going to go to Solution Explorer, pin it, right? And I'm going to go to Team Explorer, changes, pop that in there, and then commit all. And I'm going to go to home. And if I went too fast for you, that's okay, because I'm going to go to sync and push. And this is going to push up to GitHub. So you can see what I did, just in case you missed it. And by the way, this is demo for less than 10. So I'll just change that. So it says demo for less than 10, because that's what it's supposed to be. This isn't demo for less than 10. This power is not a demo for less than 10. I forgot to do this last time. This is the power class, right? And which inherits from blah, blah, blah. And I'm not going to go into more detail here. All right, so cool. We've got one part. So the power class has been rewritten, right? It's got, look, take a look what these operators look like, actually. The implementation on the class diagram is a little bit different. I didn't show this to the earlier session, right? I had some other issues. And forgive me for a session, please, whoever you were this morning, I mean this afternoon, but earlier this afternoon. Notice this, right? Operator and less than and greater than is kind of in a grayed out way, right? If I hover over them, I get my code hinting, right? Look at my code hinting coming up. It says this method overloads the greater than for use with the power class, right? So anything I write there in my comments actually comes up as code hinting, right, when I hover over it, right? Same thing with this, right? If I hover over it, it says this is the main constructor for the human class. It takes one parameter, name, which is a string, right? So anything that I hover over here in my class diagram, anything I write in my comments, my XML comments, come up, which is really, really good for code hinting. All right, cool. So this is great. I've got my one part, which is the power. I've extended the power class a little fatter now, right? But, man, how do I compare power ranks? This is another problem that I have, right? Let's go back to the program and discuss it a little bit, okay? So I want to compare two power ranks. And the supervillain has three powers here: shadow casting, mind control, and combat senses. And I want to compare, I don't know, the power rank, how much more powerful shadow casting is than combat senses. How do I do that? Think about it. I have to get access to the power ranks of these things, right? How do I get access to shadow casting, the power rank of shadow casting? Can I use, is there a class method that, or a list method that allows me to find shadow casting and compare the rank? There's no way, right? Which means we have to make it. And it's going to be a couple steps for us to do this, all right? So we'll do this and then we'll take a break, right? Because this part takes a little bit of time. All right, so we're going to go back. In this case, we're going to go to the superhuman class because both supervillain and superhero should be able to do the same things that I'm talking about, which means we're going to go up a step because that's super. If we build it into superhero, both the supervillain and the superhero can do it. All right, let's check this out. So I'm going to go back to my Solution Explorer, double click on superhuman this time, right? And now we're going to modify this class. Okay. So what do I want to do? How do I access the power list, right? How do I access the, and we need to get kind of hook into the power, right? The power that I'm looking for. I want to be able to find the power. And if I search for methods of doing this online, like for example, is there a list.find C#? Is there one? But there is, right? There's a list.find method. But the problem is it's quite complex, as you can see, right? You have to use generics. You know, it's a little bit more difficult for you guys to understand. It uses something called a predicate, which is a delegate that defines the conditions for the element to search for. Man, it's too complex for you guys right now. Would you do this in programming 3? Absolutely, because you're going to learn about delegates, right? But we can't use this, okay? That's number 1. 2, let's try list.contains, all right? List.contains. Cool, it's a generic. Again, we're really cool. But the problem is that what it returns is, it'll find it, but it just returns true or false. So that doesn't really do anything for us either. Yeah, we know it contains that power, or no, we don't. But that doesn't do anything for us, right? We want to be able to hook into that power, right? That's why we want to be able to do it. We don't get a reference to it. It doesn't return an object of type list, right? It just returns true if the item is found. Otherwise, it returns false, which is kind of useless for us, right? I want to find the index of where it is in the list, right? Now, someone from this morning says, yeah, but that index is dynamic. It's going to change. Yeah, not really. Let's try this out and see what I'm talking about. So that's what I want to do, right? But I got to make something that's private. This method is going to be private. For now, I'm going to code it as public, though, so I can test it. And then we'll go back and make it private again. So I'll make it public for now, right? And it's going to return an integer. It's going to return the index of the power if it's found. That's what I'm going to return, right? So I'm going to call it underscore get power index. That's what it's going to do. Give me the index of the power. And I need to pass in a string, the name of the power, right? That's what I'm searching for, right? And how do I do this? I want to be able, first of all, I need a counter, an index, to count where I am, where I'm physically pointing in the list. All right? Almost like, and again, this is a very crude implementation. We're going to fix this up later on. In programming 3, you're going to have better methods to do this. But for now, let's just do this. We'll say int index. We'll set it to 0, start off, and then we'll do a for each loop. Okay, and in my for each loop, I'm going to make it so that for every power in the this.powers collection, for every power in powers, right, I want to check to see if the name, right, equals if the name equals power.name. If that's true, then I want to break out of the loop. Okay, so if this name equals power.name, if name, the one I'm taking in from the get power index, whatever I'm passing into it, if it equals power.name, then break out of the loop. Now, could I use a while loop here? Sure, I could. Right? Could I use a for loop here? Probably, right? But a for loop's not great to use with the list because we don't know how long the list is, right? This way, it just loops through the entire list, okay? Worst case, it's going to go length of list times before it finds it. And all I want it to return is the first instance of the name in the power list, okay? The first instance. So if I have the name, if the hero has 25 powers, right? If the hero has 25 powers, and 2 of them they're exact same, but different power ranks for some reason, I don't know how that's possible, but let's just say that was true, right? Then it would return the first one that it found. Okay, that's what I'm trying to do here. So it's going to break, and then, but if it doesn't, if the name does not equal the power name, then increment index. Well, it's going to go to the next index, right? And then it's going to loop again. Yeah, it's going to keep doing this. But what if it doesn't find it? What if it does not find the power, right? The power doesn't exist. Index will end up being the same length, right? The index will be the same length as the how many what's everything that's in the list, the count of the list, the length of the list, right? And if that's true, so if this.powers.count, right? If the length of the list is equal to index, right? If that's true, then what I want to do is I want to say index is equal to -1. So -1 is going to say this means that we did not find the power in the list. That's what it means for us. Okay? If the index comes to the same place as the list count, then we didn't find the power in the list. And then what we're going to do is whatever we do, we're going to return. Oh, let's get out of here. At the end, we're going to return the index, whatever that is. Does that make sense? So we start off counting at 0, okay? So let's suppose we have 3 powers, right? And we're searching for the one that's the 3rd power. So let's say, for example, we're looking for combat senses. Okay, first we go through. So for each power and powers, we look through. So right now my index is 0. I start comparing. Is combat senses, does that match with shadow casting? No. Okay, cool. Increment the index. Okay, cool. Go back. Does combat senses match with mind control? No. Increment the index. Right? Cool. Does combat senses match with combat senses? Yes. Cool. Break. Now my index is going to be 2, and that's what it's going to return. What if I don't find it? It's going to be 3. And 3 is the total list length right now because there's only 3 powers in the list, right? So because the 3, it's going to return a -1, which means we didn't find anything. And that's how this algorithm is going to work, all right? Is it the only way to do it? Hell no. There's tons of ways to think about how to do this, right? This is just my convoluted way of thinking today. I just kind of made this up. All right? All right, cool. So this is my little get power index. Let's test it to see if it works, and then I'll comment it and everything else. I'm going to go back into my program code here. All right, so this is how it's going to work. We're going to say that because superhuman is the superclass for human, sorry, for supervillain, we'll do something like this. Supervillain, right, dot, and that's lowercase supervillain, by the way. Supervillain dot underscore, right, get power index. Now I know that it's private because I made an underscore, so I know I'm just testing it right now. Later on, we're going to make it private, so you can't do this anymore, right? And we're going to say something like this. What's the name of the power? The power name. Well, I'm searching for shadow casting. Let's see if we can find the first one. So shadow casting, right? Cool. Well, this is going to return a number, the index. Let's print this out. So let's print out the index, right? So we're going to take this whole thing, and we're going to put it in our console right line, and we're going to print out whatever index it finds, okay? So what number should the index return if we're looking for shadow casting here in this case? 0, right? Because it's the 0th index. And someone asked me this morning, well, Tom, that's not true because lists don't have index. They're not indexed. That's not true either, right? Lists are like lists and lists are like arrays. The order that you add them in is the order of their index, right? However, if I take a list item out, then the index will update and change, right? I'm not taking items out of the list, right? All I'm doing is checking where my shadow casting is. And right now it's an index 0. All right. So let's take a look. Control F5, and I should get 0, which is right here under malice, right? See that? And that's what I wanted. Okay, cool. Well, if that's true, then if I search for combat senses, I should get a 2. Let's see if I get 2. So combat senses. I'm looking for combat senses. I should get a 2. 0, 1, 2. Right? Let's see if that's true. So Control F5. And so we know it's working. Okay, let's look for something that doesn't exist. Spider senses, because spider senses is different than combat senses, right? So if I try this out, spider senses, and if I press Control F5, we should get a -1. Let's check this out. And -1. All right, so we know our little function that's private, our little algorithm we wrote works. We know where the index of the power is. All right, now you might say, so who cares about that? Once I know where it is, I can get the name and I can get the rank. And I can do the rest of the operations, right? So it's a little utility that I wrote to do this kind of stuff, okay? Let's check and see if I go to superhuman again. Let's do some things. Let's change this to private, because that's what this is. It should be a private integer. Returns a private method. And I want to do //. So this private method returns the index of the power name listed, or sorry, in the power list. If not found, it returns -1, right? And return returns the index of the power list, the power in the power list by name. So in other words, I take the name, I compare it to the name that might exist in the power list, and if it doesn't exist, then I'm going to get a -1. If it does exist, if that name exists in the power list, right, and the names that are inside the list, then it's going to return the index of the list that defines it. Okay. Okay, cool. So we've done this. Team Explorer. I'll put it up on GitHub for you guys so you guys can get it. Changes. And I'll say something like added private underscore get. Oh, I forgot to do something. 0.8. Added private get power index method. That's what I did. Go back to that Team Explorer to the superhuman class and commit all and home and sync and push. It's a great place to stop. We're going to take a 5-minute break. And we're going to finish off with the implementation. All right, so let's take a 5-minute break. I'm going to stop recording, and then we'll have a short recording on the implementation of this thing. All right? Or wait, do you guys want to continue? Do you want me to finish? I need another 10 minutes. Let's finish. Let's finish. All right, then we'll finish with that. All right, so okay, cool. So we've got this piece, the power index method, but we need to be able to get this stuff, right? So I need a method to be able to get at the power itself, right? So that's the private method. I need to write a public method now that the users can have access to. That's a little bit more friendly, right? So here's display powers. We never kind of went too much into detail. And maybe way here at the bottom, I've got my display skills, which I never implemented, but way at the bottom, I'll make another one. So it's public. And what I want to do here is I want to return the power That's what I'm returning. The power that's related to that, the name of the power. So I'm going to search for the power. So I'm going to return the power, get power. That's what I'm looking for. And it's going to return the power itself, a reference to the power. That's what I want. Okay. So I'm going to return power. That's what I'm returning, right? And I'm going to call this get power. And I'm going to pass in the name of the power, which is a string, right? And I'm going to return in one blow the name of the power based on the index. How do I do that? So in my powers list, right, I want to, in my square brackets, look at the index, right? I can do this. I know how to get the index now. I'm just going to call this that underscore get power index. I'm going to pass in the name, and we're good to go, right? That's all that I wanted to do there. That's all my get power does, right? Why did I do it this way, right? Why couldn't I have just made this all that other implementation public, right? Because later on, I can use this get power index in different ways, right? And it'll be internal. I can use it 4 different ways internally, right? If I shared the guts of this thing externally, right, then I would have to call an external public or public method over and over again. It's just a way of doing it. Could I have done it? Absolutely. Do I recommend it? No. Why? Because it's the inner guts of the car. Think about it. Do you know how to fix your car? No. You know how to drive your car, and that's all you want your users to do. You want them to drive the car. You don't want them to fix the car or understand how the engine works, right? That's called information hiding. And that's what I'm doing. I'm further information hiding, even though it's a very simple method. So // right? This method returns a power, right? Object that matches the name, matches the power name. Okay, hold on. We have a problem. What's the problem that you can foresee here? What can happen, right? What can happen here? I'm going to take this out for now. The risk is, what if the name's not found? If the name's not found, it's going to return a -1. And a -1 is going to go in here and cause a problem, a bug in my code, right? So I got to test for it, right? So I got to do something like this. If, and I'm going to take all this code right here, this.power that name, and this is the problem, right? Should I really do this and this again? This is bad, right? Because you know what I'm doing, right? If not equal to -1, that's what I want to do, right? This is the poor evaluation. Then I want to return this, right? Otherwise, I want to return 0, right? I want to return 0, and 0 means that the power wasn't found. But power, this is new. This is interesting. I can't return 0 because I'm returning a power type, right? And 0 is not a power type. So what do I mean? I mean a new power with a constructor that says unknown power, right? So we can't find this power. This power wasn't found, right? And the rank is going to be 0. Okay. Or we can actually put in power not found, right? Like this, power not found. But it's a power that has the power name that's called power not found, right? Returning this thing, it says power not found with a rank of 0, right? We can actually make a weird rank like -1. Some kind of way of checking to see that it's wrong. Okay. Now this is a problem. Why is this a problem? Because I'm running the for each loop once and then twice. I'm doing it twice. That's crazy. That's really inefficient if I do it this way, right? So the better way to do it is to set it up as an index. So I'm going to say int my index, that's what I really want, is equal to, I'm going to take this little thing right here, right? And I'm going to cut it. I'm going to put it in here. I'm only going to get it once, right? And then I'm going to check if my index is here and if my index is here, right? That's the same one. Does that make more sense? Because I don't want to do this twice. Every time I call the get power index method, it does the for loop again through the entire powers list. What if the guy has 25 powers or 100? I'm not saying they will. How about if the list was 1,000 long? It would do that twice. It's really, really stupid, right? So we can't do it that way. We have to do it only once. Even this is really dumb because it's a linear search. It's the worst case scenario, right? The way I'm doing it. I'm not doing a binary search. I'm not doing any other kind of thing. It's a linear search, like going from one to the other. We can implement the binary search capabilities of the list next week when we handle collections. All right? And we can make this little get power method even more efficient. Right now, it sucks. It's really inefficient because if I had 10,000 powers, it's going to go through 10,000 items potentially, worst case. Maybe the power is the last one I added. 10,000, right? It's really bad. All right, let's see if it works. And then we're done. So this get power method returns the power object that matches the power name, right? If we found a power. If not, it returns 0. If the power is not found, it returns an anonymous power object with with name of power not found. Okay, well, we can see why that is later. Okay, cool. So we got that done. We got this. We just did this. We're going to go up to here, and we added another thing in here. We added another method, right? Added the get power method, right? That's what this is. We're going to take this, and we're going to put it up on GitHub so you can get it. Go to Team Explorer, and I'm going to go to Home, and I'm going to go to Changes, drop that in there to the superhuman class. And commit all, and home, and sync, and push. We're almost done. Good, so you have it now. You have the superhuman class, all right? And you have the new superhuman class with this get power method. Cool, now let's test it. Let's go to program. And what I want to finally test my overloaded method. This, all the work we did is to implement this thing, right? So what can I do now? Well, I can do something like this, right? If supervillain, right, dot get power, right? If supervillain dot get power, right, and then I want to type in shadow casting, right? If that power is greater than supervillain dot get power, right? Combat senses. To give you an idea, if that's true, then, and I'm going to put it over 2 lines. I'm going to split it across 2 lines so you can see it. There it is. If my shadow casting is greater than my combat senses, because I'm overloading the combat, the greater than sign to do this, right? Then shadow casting power rank is, or shadow casting is more powerful. We'll say it's more powerful than combat senses. Okay, now, what if, let's do this again. Let's compare, instead of shadow casting, let's compare combat senses with mind control. So we'll do the other way around. So we'll say, if combat senses is greater than mind control, to give you an idea, mind control, right? Then say combat senses is more powerful than mind control. Combat senses is more powerful than mind control, which is not true, by the way. Else, and this is where you need the other comparison. Remember I said we need both comparisons? Here it is, right? Because when I put else, we're using an implicit if then else. If this, then it's less than. Check if it's less than, right? Then console write line. In other cases, when it's less, combat senses is weaker than mind control, which is what you should say, right? So we can compare whatever I want. I'm overloaded the greater than sign to compare two powers. Now you may say, Tom, who cares in the greater scheme of things? Why do we care about if one power is greater than another? Well, maybe we don't care right now, but if we're making a superhero versus villain game, right? Maybe we will care, right? Maybe we will care. An example of this would be, what if I was doing a super punch on a person's body armor, and my super punch's ability, the damage that my super punch would do is greater than the body armor. I can use an overloaded method for that. I can check. If it's greater, then do this. Maybe there's an effect. Maybe he gets, not only takes damage, but he gets slammed back, or he gets knocked down or something. I don't know, right? There's all kinds of ways you can use this. And at the end of the day, what we use this for, my friends, is to save code, believe it or not. It's not just for special effects. It's to save code. It creates, we want to try and match the business case as much as possible, as close as we can. And so overloaded operators allow us to do this. Okay, let's test it and see if it works. Control F5. Bam! Shadow casting is more powerful than combat senses, but combat senses is weaker than mind control, which is true. Right? Why? Take a look. Shadow casting is 50, combat senses is 30, but mind control is 40, and combat senses is 30, which means combat senses is weaker than mind control. And so we can check the ranks. So it did a couple things here. It found the power in the power list and compared the ranks. And that's what the overloaded operators allowed us to do. Whew, crazy. All right, let's put this up on GitHub so you can see it. So 0.9, we'll say implemented the supervillain less than and greater than overloaded operators. Okay, so I'm going to take this whole thing, copy it. I'm going to go to team. I'm going to go to home. I'm going to go to changes. I'm going to put that in. And you may not understand this, and it's okay. 100%, you may not understand this. But I want you to ask questions next day. So next day when we get together on Thursday, if you don't get this, ask me questions, because we're going to get more complex from here, right? It's not going to be easier. And I don't want to lose you guys, right? I don't want to sit there and go, well, they don't get it. So does anyone have any questions before we depart for this? It's kind of a 2-hour video. I apologize. Went a little long today compared to normal. I promise the next day we won't do a 2-hour video, right? Because we're going to have that little quiz. We're going to have some practice that we're going to do next day. So on Thursday. All right. So be aware, again, Thursday, there will be a quiz. Just reminding you at the beginning and the end of the video here that it's going to be probably around 10 questions, around that amount. It's going to be worth 0.5% of your final grade. And I'm going to be talking about GitHub on the quiz. Ask you questions about GitHub. I'm going to ask you questions about inheritance. I'm going to ask you questions about polymorphism, right? Concepts we're talking about, okay? I'm going to talk about interfaces. I'm going to talk about abstract classes, most likely. There's like all these questions I'm talking about, right? And no 2 quizzes will be the same, right? Because I'm going to have a big pool of questions. So you may get more questions about polymorphism than somebody else, or more questions about GitHub than somebody else. It's all going to be random, okay? Any questions? All right, see you guys on Thursday. Thank you. The what? It's going to be online, yeah. It's going to be an online quiz. Thank you.